Welcome everyone to this week's IPLD sync meeting. It's May 25th, 2020. And as every week, we go over the stuff that we've done last week and the stuff we might work on next week, and then discuss any open items we might have. Today, it's probably not such a packed meeting because there's a holiday in the US, but it doesn't stop us from meeting. So I started with myself. I'm still working on the blog API. And combined with this one, I want to make sure that the IPLD stuff is generic over the coding tables. I think we've discussed this a lot in previous meetings as well, that it's very important that you can pass on your custom coding table and we don't bundle huge tables with the implementations. And I was stuck with a small point, which is getting an actual coding implementation based on such a code. So let's say you want to have DEX-CBOR and you only have the integer value getting the actual codec, which seems pretty straightforward if you think about other implementations, but in Rust with the current implementation, it's not. But luckily today, at the end of the day, I found a solution, I think, which is exactly, I think, what I would need for the blog API. It is not as general as it could be, but the general case really doesn't work the way things are implemented. But the way things are implemented, I think, makes sense. So it's totally fine to say, I use this special case. I will probably say more next week when I really if I found out that things actually work, because there's no point of talking about things that then in the end don't really work. Sometimes there's a point, but I don't think in this case. Yes, then just, I haven't done any other IPLD stuff last week, I think. Next on my list is Eric.
Shoot, I did it bad. I was still typing. I did a bunch of things this week, most of which I've probably forgot and will think of too late to report on. But Go CodeGen got some major progress this week. Lists and maps now both work fully recursively. And okay, that's not news, but what is that includes recursion when they're in representation mode. So previously, this was a kind of sizable to-do. If you were traversing over a recursive structure, you could start in representation mode, but then when you traversed into its children, they would forget that they were in representation mode. So like you could be partway through a structure and like maybe the struct inside of this map is supposed to be a string join representation of a struct or something. And you would traverse into this and you would forget that you're in representation mode. And so the node interface you would get back would continue acting like a map. And what you actually want is the one that acts like a string for that structure, right? So it would do the wrong thing. Now, long story short, it does the right thing. So if you ask for some node value and you get the representation on it at the root of some big tree of data, if you now pass that node to like any of the regular traversal things, or for example, regular codec marshalling, it'll just transparently do the right thing because all of the recursion will stay in representation mode. And so codecs now transparently understand code-generated type serialization. Cool. Lots more documentation is also appearing in the Go CodeGen. I, out of some amount of horror, took a look at the sheer size. There's over 100 kilobytes of README and HACME files now. There's a lot of design choices that need recording there. So that's fun if anyone wants to read. And there was an interesting discussion in the GitHubs lately where somebody asked, do we have selectors for byte ranges? And the answer was no, but we should. And so there's some really nice discussion that went on over there. I'm overjoyed to say I got a heart emoji reaction from the poster of that. So I feel like I won the internet and I won GitHub. And thank you, random internet stranger. The little things really do make all the difference. Made my week feel great. So, and probably other things, but I've forgotten them. So I'll rest there.
Thanks. Next is Rod.
Okay. I have so it's all been Bitcoin for me, which I'm frankly getting completely sick of, but I'm mostly at an end to it. Now I just want to list through the things that I've done. So I've now processed the entire blockchain in the way that I needed to, and I have tools and code to show for it. So I'm listing things in the notes in the hackpad. The main thing is in the IPLD org, JS IPLD Bitcoin pull request number 63 is where the bulk of my work in the last couple of weeks has been, and we're talking about pulling that out into a separate repo because it's basically a complete rewrite of the JS IPLD Bitcoin code. So, and it's not compatible with the old one. It's compatible with the new JS multi-formats work. So we're going to put that in a new repo, publish it as a different name, and then make a break with the past, and then sort of say new stuff here, old stuff there. That I'm still working on documentation in that one. I'm chipping away at getting API docs right now, and other than that, it's pretty much done. In my GitHub, the JS Bitcoin block does the encoding and decoding work for the Bitcoin format. That's had to have little bits adjusted over the last few weeks as I've encountered these unicorn blocks, as I'm calling them, in the blockchain. Just blocks that have got unexpected features, and you know, I think we were talking last week about how there's a financial incentive in the blockchain for novelty, and that makes a really interesting case study in these unicorn blocks. Yeah, there's a bunch of them, and my test fixtures are listed with these unicorn blocks now. I can identify a bunch of them and say what's particular about them that makes them stand out. But I've done the whole blockchain now, so I found them all. There's another repo in my GitHub called JS Bitcoin Extract. It's just a bunch of utilities to extract the data from Bitcoin Core to verify, to IPLDify, and which also verifies that it can go the reverse way. Then the consolidation to 1 gig car files, which was the aim of this project. And then I also have another utility that verifies that those 1 gig car files can be re-serialized back into the original binary format. And I've actually I think that's still running. I've got that running on my machine. Yeah, so it's just doing a verification. It seems to be fine. There's no problem there. And lastly, there's a pull request 176 in the multi-codec, in the multi-format / multi-codec repo for the multi-codecs table to add one more multi-codec for Bitcoin called Bitcoin Witness Commitment, which is code B2. And that's for this one little data structure that is needed to pull this all off. So we've got 3 codecs now for Bitcoin. And I've had enough. But the plan is to moving on to other blockchains, and I think at the moment, this is not firm, but I have started looking at Bitcoin Cash, and I might do Bitcoin SV as well, because these are hard forks of the blockchain, which means that their code is very close to the original Bitcoin code, and I can start processing from the fork point onwards, so I don't have to have the whole blockchain. I just have to have up until their fork point, because I've already got the Bitcoin blockchain, the rest of it done. So that might be easy to do. but then alternatives are other Bitcoin code forks, which there are a lot of. So choosing some popular ones. But this work is getting a bit tedious, so I think I have to sprinkle that in with some other work, including getting back to my JavaScript CBOR parser. Sorry, CBOR encoder and decoder, which was very close to having the basic functionality done, and I wouldn't mind getting back to that. But I do have a bunch of other things that are sort of on my plate that I need to scatter in there. But just to keep myself sane, I think I need to not focus on this 100% because it's it's quite consuming, I'm finding. Anyway, that's me.
Thanks. Peter, do you have any updates or anything you want to share?
Not really. One thing that's interesting and new is that base 36 is becoming a thing now in IPFS land, because we basically ran out of space for 32-bit keys in subdomains. And if we encode stuff in base 36 instead of base 32, we fit exactly right. So different text representations might start flying around. Don't get startled. Other than that, not really. I'm still working on my stream processor tool. It's more or less the code is all there, but still have to document the concept sufficiently well because it turned out to be more complicated than I wanted. And hopefully I'll be sharing this with you guys next Monday with actual examples and stuff like that. But the bottom line is that it likely will be very easy to retool this to do Unix FSV2 or any other kind of CBOR-based work as tests, because it does streams out to cars, and it basically interoperates with everything else. So with a lot less code. So yeah, next Monday.
Peter, can you explain the context for base 36 a bit more, because this seemed to come on very suddenly, and I didn't see the logical context for why we were doing it.
Because I just mentioned it because it kind of consumed my entire weekend figuring out how to efficiently encode base 36. I will link the issue in a moment once I find it, but the bottom line is that there are use cases where we would like to use EC20, what was it, 2295 keys as part, the actual PRIDs as part of the subdomain. And the way we're encoding currently libp2p keys with all the overhead around them, once you encode it in base 32, is 65 bytes long, which is 2 bytes longer than a DNS subpart. And while we don't care about DNS that much, everything out there, when it parses, even Slack, when it parses URLs in text, it will cut things out at 63 bytes. So whenever you do something that's URI looking, you have to have every part of the secure portion of the URI be at most 63 bytes. And this is why we are introducing support for base 36 encoded CIDs, because then everything fits within the limits that we work with. There is a discussion whether we would want to switch everything to base 36 or just use base 36 in basically in the URL. But yeah, work in progress on that.
Okay, so these are all these are lowercase, I assume. So what's the main difference with what are they looking like with from base 32? Are they What other characters are we adding in there?
So we decided on K as the actual prefix, just like B is for base 32 and Z is for Bitcoin base 58. And they're case insensitive from 0 to 9 and from A to Z. Any case mixing will work correctly. And that's that. And I will link in a moment the actual test cases.
Well done.
Okay. Is there anything else anyone wants to talk about? If not, then I close the meeting. This time was a short one again. So thanks everyone for your time and see you all next week. Goodbye.